Hi, my name is Dr.AhMath. Welcome to the course of Biophysics 1. So this is one of the fascinating topics which we're going to discuss in this course. It's called the heart anatomy. We're going to look to the anatomy of the heart from the perspective of its electric conduction system. So our final goal is to understand the ECG. So basically we would like to try to understand what does it mean those waves on the ECG. And in order to try to understand this, we need to try to understand the structure of the heart, and also we need to try to understand its system through which the electric charge is passing through. So first of all, we need to look to the heart, and we need to divide this heart to the four parts, basically. So the upper part is going to be called as the atrium, and the lower part is going to be called the ventricle. So one thing which you need to remember is so the orientation in the hertz is like mirrored. It means that if you look to the heart, so in order to try to understand the orientation of the heart, you need to assume that you are looking to me from the heart, from inside of the heart. You're looking to me. So that is why this part is going to be called as a right atrium. So this one is going to be called the left atrium, so right ventricle, and the left ventricle. So let's try to understand how actually heart is working. So usually the atrium contracts, then the ventricular contracts, then it relaxes. Contracts, then relaxes. Contracts, atrium contracts, and then ventricle contracts, and then it relaxes. So this actually happens because of this complicated electric charge conduction system of the heart. And actually, so there is an electronic conduction system that is made from the cardiac muscle cells, which we're going to call as the myocardiocytes. And the action potential actually is propagates through the myocardiocytes. And we need to try to understand how it happens. So in order to try to understand this, again, we need to try to divide this. So the action potential actually is created in different parts of the hertz. So the different parts of the hertz can create the different action potentials, actually, different beats. So the main beat maker or pacemaker of the heart is located on the right top corner of the right atrium. So this is called as SA node or sinoatrial node. So this is the main pacemaker of the heart, so it creates the beat of the heart. So once it creates the action potential, so the beat, so the signal is transmitted to the AV node, which is located on the bottom left corner of the right atrium. So the signal which is transmitted from the SA node to the AV node is then going to be transmitted to the AV bundle, or it's also called as a bundle of His, which is located exactly in the middle between the right and left ventricles. So the bundles are going to be split into the two parts, to one and the second ventricle, and the signal is going to be transmitted over there. So these two bundles we're going to call as a left and right bundle branches, or just the bundle branches. Then the signal is going to be transmitted at the end to the Purkinje fibers. So at this stage, if we hold on this picture, so the signal, which is, or the action potential, which is created at the SA node, is basically propagates through all of the hertz until the Purkinje fibers and depolarize all the myocardiocytes. And at this stage, it's like everything is it's plus inside and minus outside. Then after a while, everything becomes negative. So it basically repolarizes. So this is actually how the signal is transmitted in the heart. So we are going to talk about this. So this four parts of the electric conduction system a little bit in more details. So SA node is the autonomous pacemaker center, which is able to create 60 to 100 beats per minute. So when the signal is transmitted to the AV node is at the same time is also is able to create a beat from 40 to the 60 beats per minute. But actually, normally, so the action potential, which is coming from the SA node, overrides the AV node's own pacemaker activity. But at the same time, if there is a block, so if something blocks the signal, which is coming from the SA node to the AV node is still able to create a beat. Then when the signal is transmitted to this, so this part is called the AV bundle, so which is also is able to create the beats from 40 to the 60 beats per minute. AV branches, so the bundle branches are also able to create the beats from 20 to the 40, and even the Purkinje fibers are able to create the beats from 20 to the 40. But actually, all of the three parts used as the conduction, as to conduct the electric action potential. So, and so as I told you, so you have seen that all of these parts of the heart are able to create its own beat, its own action potential. And the shape of the action potential, which is created by, for example, SA node, is going to be really different than the shape of the action potential, which is created by the AV node. So let's look briefly to the shapes of the action potentials which are created by the different parts of the heart. For example, the action potential which is created by the SA node is going to look like as very similar to the action potential which is created as a nerve in the nerves, and the AV node is going to be very much similar to the SA node, and the bundle of his is going to be slightly different. So then action potential of the bundle branches, it can look like this, and the Purkinje fibers can look like this. If you remember, so this part of the action potential is called the plateau. So this is also important for us. So you can see that like the heart works really as a symphony. So with a bell timing system. So basically the atrium contracts, then the ventricular contracts, then everything relaxes. It's like contracts, relax, contracts, relax. So the pacemaker and electric conduction system of a heart is a perfectly well-timed symphony. And the ECG basically measures its coordination. So basically, so all of this timing is really important to functioning of the heart. And the ECG basically traces the propagation of the signal from the SA node until the Purkinje fibers, and it can tell us if something is going wrong. So in our next lecture, we're going to talk about what is ECG.